Hi, I'm Brian Malow, and we are live from Lindau, Germany, a beautiful medieval island on Lake Constance in southern Germany. And it's the site of the 74th Lindau Nobel Laureate meeting. This year's a chemistry meeting, and there are about 30 Nobel laureates, mostly chemists, but not exclusively, and more than 600 young scientists, also mostly chemists. And they come from as many as 80 different countries. And I'm happy to be talking to Giulia Frigerio.
Yeah.
And you're from Italy and you're still working in Italy?
Yes, I am.
Where are you and what institute?
I'm based in Milan. I'm working at the Department of Material Science at University of Milano Bicocca, which is in
Excellent.
Milan. Yeah.
And where are you in your career?
So I'm a postdoc. I recently started my postdoc. I defended my PhD thesis in February.
I think we're being photobombed by very loud dinosaurs. So you started your postdoc in
That's science.
February, very new.
Yeah, and so I also did my PhD in the same institution. And back before that, I studied chemistry, bachelor and master in chemistry at the same university too. So that's a place I like, as you can tell. But I also spent 6 months in the U.S. in Boston at Boston University during my PhD for a visiting PhD student period.
Excellent. And what type of chemistry are you like a theorist or applied or practice? Do you work in a lab?
So I don't work in a lab. I work in a computational lab, which means we work at the computer and we're basically doing our experiments in the computer. So we are making models of our systems and then let them evolve under physical laws, and chemistry is involved, of course, and then we study the results. So that's the kind of work that I do, but we do collaborate a lot with experimental people to kind of connect our ideas and complement our findings to get to something bigger, to achieve something bigger.
Every year there are different themes to the in addition to being whether it's a physics meeting or medicine physiology or chemistry, there are some additional themes. And one of the themes this year is about using AI tools in chemistry. Is that relevant to your work?
It is in some sense. So I use the AI mainly to analyze my data, because what I do on a daily basis is to run molecular dynamic simulations. These simulations will give you a sort of movie of your system in time, and then it's like you are looking at this movie, which can be thousands of snapshots long, and you don't want to really look at each of these snapshots one by yourself. So you kind of we use AI to extract relevant data from this long simulation that we did and get some relevant information. In my case, for example, we were interested in how a drug binds to a nanomaterial. Why is that? Because we want to use nanomaterials for drug delivery. So to improve the selectivity of drug delivery, only to deliver them only to the target cells we are targeting. So for example, cancer cells. So for cancer treatment, the biggest issue is that the drug goes throughout the body, reaches all the cells, and then not only cancer cells, but also healthy cells will die, and that's what we don't want to
So really
do.
targeted application,
So,
yeah, because chemotherapy is hard on the whole body when you're only trying to attack a specific little area.
Yeah, that's the point. So to improve that, you can design selective therapies, and one way of doing that is to carry your drug, the drugs that are normally used, already in use, but to carry it on a nanomaterial, which works like a spaceship or a shuttle, to carry this drug exactly where you want it to be active.
So there's something about the nanomaterial that you're using for delivery. There's something about it. There's something in the tumor cell that you key into, that's something that's unique to a tumor cell.
Yeah. So we are attaching to these nanomaterials some molecules. So it's like a probe that will bind to some receptor, so some kind of protein, which is on the surface of cancer cells. So like a spaceship, as I said, it has to perfectly match the docking ship. And then when this happens, the cargo is released. So that's the same thing with the drug.
Nice analogy. Good science communication,
Oh,
one of
thank
the other
you.
themes here. And
That's
so,
something I really care about, science
yeah,
communication. Yeah, that's a topic. So I have limited experience, I have to say, but I did go to some high schools and give lectures to high school students exactly talking about this topic, which is nanomedicine, so the use of nanomaterials in medicine, and also drug development, which is something I'm really interested in. And so I do think that we need to communicate science better, because science is wonderful and it's like the base of everything we do, like of ourselves. And so to really tell people that science is not something dangerous or, yeah, kind of like that, but it's really what we're made of. And it's so wonderful to understand what's going on.
and I want to elaborate on that a little bit because as you were describing what you do, you like what you do. What is it that you like so much about your actual work? What gets you out of bed to work each day? What do you love about it?
So I like to see what happens at a molecular level. So really looking at the atoms, what they're doing, how these molecules are interacting, or these nanomaterials. So that's what yeah, inspires me. And it's like some people did some analogy with computational techniques and microscope. They say that it's a computational microscope. So when when you use a microscope, you look at very tiny things, and that's an experimental work, let's say. But we are doing the same on our computers. So what we are looking at, it's not real. It's a model, but it's a model of what's real. So we are looking at atoms, playing around with atoms, and yeah. So
And then you compare it, or other experimentalists compare it to you based on these models. You're making predictions,
yeah,
and then experimentalists compare it to reality.
yeah, that's exactly. We compare with experiments, and to sometimes experimental techniques are not do not have high resolution enough, like to reach atomic details. So that's the point where we can match with experiments. So maybe they see a macroscopic effect, so I don't know, solution effect, like something big, and we are trying to understand what's the molecular origin of that effect. Also, I'm really passionate about drug development, as I told you. So how a drug really interacts with the protein we're targeting, for example, and what's the molecular basis of treatment or of a disease. That's what yeah, I'm really
Yeah.
looking for to understand. And
Did you always love science? Was there anything like, did you always know you wanted to be a scientist? Was there anything that sort of turned you on to science, or did you ever have a mentor or that inspired you? Tell us something about your path into
so
science.
I think I always wanted to be a scientist inside, really deeply inside me. But for some time, I took a different path, let's say. So in my high school, I did attend a classical high school in Italy, which means that I got to study Latin and Greek, ancient Latin and Greek, and really a little bit of science compared to scientific high school, how we call it. But my science teacher was teaching us biology and chemistry in high school, was really good. She was really, really good. And she somehow inspired me, but also even before that, when I was a child, I kept asking questions to my parents. My mom still remembers that I was keeping asking questions, and I was wandering around looking at nature, like, okay, what's this flower? What's this animal? The insects, like stuff like that. I was just curious.
Nice, very excellent. Now, as you know, this meeting is uh, it's not just a scientific meeting. It's essentially about mentorship, and the motto is educate, inspire, connect. And let's talk about the meeting for a few minutes, and then I'll let you
Sure.
get back to it, because I know if you're talking to me, you're missing out on something interesting that's happening. Someone's giving a lecture, or there's a panel discussion. And so, what do you think of the meeting so far?
I love it. I totally love it. So I was waiting for this meeting for a long time. I was waiting for the chemistry one because I'm a chemist, and the last one was few years ago, I don't know. So I was waiting, and I was okay when the application opened. I was like, I have to get this meeting, and so I'm really happy to be here, and I am enjoying it a lot. All the parts of it. So I can start from what we do for most of the time, which is connecting to other people who can be a young scientist as I am, or Nobel laureates who are just there close to you, and you just talk to them as easily as you are talking with some young people as you are. So that's the part I like, that there is no boundary. We are always we are all really happy to be here. That's what I feel like, and we are open to talk to everyone, and that's really important. And we are talking about very important issues, even politics related, and so I think this is also something important and relevant to this meeting, and the fact that it's so international, so well organized. These are all important aspects. Yeah.
Excellent. Did that surprise you, how easy it is to talk to the laureates and how
Yes,
accessible they are?
Yeah, it does. It does. Yeah, we have both open exchanges sessions where you really like, maybe it's 50 of us in the room, but we really have a long time, like an hour and a half to ask questions. We do really get the opportunity to ask questions. And then we have these Laureate lunches or science walks with Laureate Nobel laureates. Yeah. And there there's only 10 of you, and that's also a very nice thing. But even if you didn't book a lunch or walk, you can talk to Nobel laureates at the cafe or.
And at every dinner, maybe at some conferences, if there are 50 dinner tables, all the VIPs would be at one table, but here that's not even allowed.
No.
At every table, there's a placard with one Nobel laureate name, and then that's the only assigned seating. The laureates are one per table, and then the young scientists, you just look around and go, I want to sit at his table.
Yeah, indeed. And you can really sit close to them, and you're gonna talk about science, of course, but also normal life, like daily life, and that's really good because you kind of get the feeling that we are all people, and some of them, they really tell you, like, I was not aiming for a Nobel Prize. I got really many problems in my path. I changed my path a lot of times, and still I'm here. And also something else I appreciated from the first day, that it was told that winning this prize is actually a lot of luck. And so there are many more scientists that would deserve the prize, but they didn't get it because of many reasons. And so really, appreciating science as a whole, I think it's something.
Yeah, I liked hearing that too, that of course you do good work, and one part of the luck is that you happen to be working on the right problem at the right time.
Yes.
And, so that's not predictable. So you're a young scientist, but to other young scientists in general, and maybe even some that might think about applying to this meeting, anything that you have to say? I mean, what you just said was really interesting.
I'm not sure who is in the audience. If there is any Italian young scientist, just go through the open application. It will work. Just contact me if you have any issue or doubts. I thought it was because, okay, you can get nominated for this meeting, or you can go through an open application. And I thought this would have been impossible. Like, an open application with many other people, why would they select you? But you can really, like, if you fill in the form very well. I mean, I think I did it, and I'm not anyone special. So just to apply. It's a lot of fun, a lot of connections. Even if at some point you decide to drop science, you will have many friends around the world. And I'm sure you are like loving science if you're coming here. So in any case, you will get to know important people in your field and get inspiration from them. So I think it's really worth it. And just try it. Don't be scared of the open application. That's what I did. But
it's worth the payoff could be great.
Yeah.
Thank you very much. And We'll be back throughout the day with some more live interviews from some of the young scientists here at the 74th Lindau Nobel Laureate meeting.
Thank you.